And welcome everybody to the daily space weather. We're looking at the sun and colorized magnetogram. We saw a couple C-class solar flares happen in the past 24. Also a new sunspot group forming up here. Right in the Earth-facing zone here, sunspot 2832 is what that group is likely to get named if it continues building as it has. Here's another view in the UV spectrum, also from the Solar Dynamics Observatory. Great view of that forming sunspot region there, sunspot 2832. We'll see if it lasts 12 hours or more. Also, coronal holes rotating in here associated with the South Pole once again. And how about 94 angstroms? You'll see up here in the northwestern limb some brightening. That is the C-class solar flares that came out of those setting sunspot groups. Another prime example of how sunspots are most likely to produce large flares around the limbs than when facing the Earth. It has to do with the emissivity of metals and the likelihood that the sun is indeed internally made of metals. Next, looking at a chart of the solar system. As we approach new moon tomorrow, we'll advance this map 1 week. As Mercury swings between the Earth and the sun, here's a star chart. If you're up before dawn, you may see Jupiter and Saturn near the peak of the ecliptic. In your southern skies, if you're in the northern hemisphere, the location of the ecliptic, which is this yellow line, the path which the sun takes across the sky. That's in-the-sky.org, by the way. Just put in your location if you want to make yourself a star chart. And I ask you, where were you when Deneb rose? Where were you when Deneb rose? Next, looking at the radio flux, it's at 80 solar flux units, which is equivalent to 10,000 joules, by the way. And the radio flux is the most proportional data set we have to sunspot number. Again, at 80, there's the 1-year chart. The black line is the radio flux. The red line is the sunspot number. The blue line is the Potsdam AP, the Planetary Magnetic Field Index. We don't see any solar storms or anything on the horizon here forecasted. Calm conditions expected over the next 3 days. Let's check global seismicity. What's going on with earthquakes? There's the 90-day bar graph of earthquakes, courtesy volcanodiscovery.com. And here we've sorted by magnitude, a number of 4 magnitudes, nothing over a 5 magnitude. So I think the largest was a 5.7, which was, I think, this one down here at Papua New Guinea nearly 1 day ago from when we made the video. Let's check the list here on USGS. Indeed, that was the largest of the past 24. A 5.7 at Papua New Guinea at depth, nearly 140 kilometers depth for that quake. There was also a 5.3 at Japan. Otherwise, pretty calm when it comes to earthquakes. A small swarm of quakes in the Caribbean as well occurred. How about a 3.5 in western Texas? And an extremely shallow quake at Hawaii. Let's check the location of that. I'll bet it's under Mauna Loa. What do you think? Quite well situated under the main caldera of Mauna Loa there. Again, that quake at 1,300 meters above sea level. Let's see what's going on with other volcanoes. Karimsky on the Kamchatka Peninsula is now on the list, though volcanic ash not identifiable in satellite imagery. Suwanosejima also erupted, flight level 070. It's produced a 7,000-foot plume of ash. Krakatoa now back on the list, producing some minor volcanic ash plumes, as well as about 50 magmatic earthquakes. Exclusion area established at 2 kilometers from the main crater at Krakatoa. The Great Sitkin volcano in the Aleutian Islands has produced a lahar, probably from melting snow. Sangay in Ecuador exploding, 19,500 foot ash plume above it. Revenador exploding as well in that same nation, 15,000 foot ash plume above the Revenador volcano. Sabancaya, unable to detect, just like Nevados de Chilean. And though we're unable to detect whether or not they're erupting, you should assume they are. And please do not pole vault the caldera. This public service message brought to you by smAsho.com, and check out our Redbubble shop listed in the links below the video. We've discounted everything, all 7 designs throughout the month of June. Next, looking at solar flares, you can see 3 C-class solar flares happen in the past 24 hours. And they all came out of those setting sunspot groups in the northwestern limb. That's your 3-day chart for solar flaring from the GOES-16. No spikes in the proton flux. No surprises there, as no coronal mass ejections have been going on, at least not in the Earth-facing zone. In fact, I don't think any period have been going on. There are some filaments out there, though. So, next, the GOES magnetometer. Here's a 3-day chart of that. And we're seeing pretty low highs and pretty high lows. A tighter range in the past 36 hours, I'll say. Next, looking at the heliospheric current sheet. Here's the polarity of that. And if you're wondering where the data comes from, it's from 51 ground-based magnetometers, as well as magnetometers out here at Lagrangian point 4 on stereo A and Lagrangian point 5 on stereo B. Little bit of indecision regarding the polarity in the Earth zone here. Earth still in a South Pole-oriented current sheet. Don't be surprised to see that suddenly change, especially if we see some activity rising in the southeast. So look for that. Here's a line of sight ecliptic plane field plot. It's the same data as this, just showing you the line of sight view and the solar magnetogram. And here's the coronal hole plot, which shows you the sun's B field in blue. Those blue potential field surface source lines are the sun's B field, a product of the 2 overlapping solar polar fields. You can see those coronal holes rotating in here, south-oriented ones shown in red. And here's a visualization of that. You can see these coronal holes down here just showing up on the detected coronal holes map. And up here you can see sunspot 2832. Right there at the end of the video, showing up as an alpha class. I think it's already beta class. We'll analyze that toward the end of the video. Global geomagnetism is quite calm here, having reached geomagnetic unrest conditions for a brief period of 3 hours or less late in the day on the 7th. Current conditions are KP of 2. Global geomagnetism quite calm. Next, looking at the real-time solar wind. To see fairly uneventful solar wind here over the past 24 hours. Current solar wind conditions are 4.75 protons per cubic centimeter for the density. Solar wind speed, just under 400 kilometers per second there, shown at 392 kilometers per second. Next 4 hours of geospace magnetosphere movies, showing the main magnetohydrodynamic pressure on the magnetotail region, the side of the Earth not facing the sun, as we see a fairly diffuse solar wind at only around 5 protons per cubic centimeter. This is showing you magnetohydrodynamic pressure in nanopascals. Since it refreshed, we let it run all the way through. We try not to edit the videos to get them released as quickly as possible. Also, don't forget to check out our cosmology and meteorology segments. Anyway, there's 4 hours of data on that. Here are ground magnetic perturbations. And we're seeing some perturbations here south of South America on the Antarctic continent. despite the south geomagnetic pole being someplace around here where my pointer is. We also see magnetic pulses coming out of the Pacific Ocean. You can see right there, just to the west of Hawaii, the sort of the epicenter of those magnetic perturbations there from the Pacific Ocean. And like the other geospace magnetosphere movie, this is 4 hours of data. It's all courtesy of University of Michigan. It's all based on the space weather modeling framework. If you want to read about it, scroll down, click on details, and you can find where the data is derived for that. And we've just done our cosmology segment. Don't forget to check that out. Daily Space Weather viewers. Next, we're talking electrons, which have the capacity to charge up satellites. But we're seeing low electron densities right now and no charging hazards. Here's the 1-year chart of the electron flux, and you can see these low levels as we forecasted yesterday. Here's a 3-day chart of the electron flux, and it's pretty chill when it comes to electrons. Here's the forecast, which I nailed. I pretty much said it was going to be exactly there. NOAA is agreeing with my forecast for tomorrow as well. We're expecting an uptick in the electron flux. It might take 2 days for it to show up, but we're expecting this uptick indeed to happen, as is NOAA. The green boxes are the forecast, and the yellow diamonds are the observation. Next, looking at the total electron content forecast, and we saw anomalies in it yesterday. If you didn't see yesterday's daily space weather video, check it out. You can find all of our playlists at youtube.com/smashomash/playlists. And things are looking a little bit more normal here, although we are seeing some likelihood of GPS errors at nighttime on this run. Here's a diagram of the Van Allen belts that surround Earth and distances in miles. Here's another diagram of the atmosphere to show you where the F layer is, because that's what we're going to show you next, the F ionosphere layer, located at about 300 kilometers of altitude in vibrational frequency. So you're looking at megahertz. Each blob of color here represents 1 million vibrations per second difference between the other colored blobs. And the ionosphere is looking a little anomalous here. Once again, we're seeing a very wide band of low frequency portions on the nighttime side. Daytime side looking a little bit more normal. And here's the latest image coming through at 9 o'clock Universal Time. A little discharge on the sun-facing side there. Otherwise, pretty normal. Next, it's time for a meteorology segment. Make sure you check that out. If you haven't, it'll be a separate video from the Daily Space Weather. And it's time for bonus features on the Daily Space Weather. Let's start out with the latest imagery from Udaipur, India, from their ground-based solar observatory, looking at hydrogen alpha on the closest star. There are quite a few filaments, actually, right now, folks. You can see filaments over here, filaments here, filaments, which do indeed increase the likelihood of a coronal mass ejection. Let's take a look at the latest high-res imagery. And you can see likely sunspot 2832 up here. That is beta class, I believe. Let's make sure. And indeed, we can see umbrae associated with the North Pole and the South Pole, making it a beta class sunspot. So there's that. Next, I'd like to thank our patrons. Thanks, patrons, for being the true source of funding for the content for these videos, increasing the probability that these videos will continue to exist. And if you're viewing the videos and you're not a patron, you should thank our patrons too if you enjoy the content. Consider becoming a patron for all kinds of perks at patreon.com/smashomash. And we'll close things out with 2 more full disk images of the closest star. Here's 304 angstroms, which is ionized helium. And a great view here of all of the filaments around the limbs. This little episode down here did not appear to produce a coronal mass ejection. It probably splashed back onto the chromosphere. And here's 171 angstroms, my personal favorite wavelength. Thanks for tuning in, folks. Don't forget to check out our other videos. We produced a meteorology and a cosmology segment today as well. Also, don't forget to view our live stream today at 2 p.m. Eastern Daylight Time. 2 to 3 or 3:30 p.m. we'll be streaming live on Wednesday afternoons. In any case, thanks once again for watching the videos, and may that solar wind be at your back.